Hey everyone, welcome back, or if you're just joining us, welcome to KSSP Podcast. I'm Spencer,
And I'm Katie.
and in this episode of our series today, we're going to be talking about a stellar nebula. So, what is it? The nebulosity surrounding a star is the star's shell or envelope of nebulosity, and a nebula is a giant cloud of dust and gas in space. Some nebulae, more than one nebula, come from the gas and dust thrown out by the explosion of a dying star, such as a supernova. Other nebulae are regions where new stars are beginning to form.
So, how do they work? All stars form a nebulae, which are huge clouds of gas and dust. Inside stellar nebulae, space dust, hydrogen, helium, and plasma swirl around and stick together and form into large blobs. These blobs eventually collapse, and the stuff inside begins to heat up. As more particles are pulled into the hot center, they eventually become a star. The process of star formation takes around a million years from the time the initial gas cloud starts to collapse until the star is created and shines like the sun. The leftover material from the star's birth is used to create planets and other objects that orbit the central star.
And then we're just gonna briefly go over two. So, this is a series on NASA, just talking about how I think a planetary system is born and dies. It just goes over the whole birth of one. But for now, we're just going to go over chapter 1 and chapter 2. So, chapter 1 is A Star is Born, which is in their timeline 0 to 100,000 years. So, as we know, the molecules of hydrogen and helium clump, slow down, and clump together because of gravity. Then there's tiny grains of silicates, iron, and carbon-rich material, which are together classified simply as dust, send some of the gas's energy back out into space, making the cloud even colder. So these clouds are very cold. So as we know, gravity plays a big part in kind of pulling everything together to form the star. While the infant star takes shape, the material spiraling inward flattens into a pancake-like structure known as an accretion disk. So, how do we know what kind of star will form in these? And that is going to depend on the material available. So I'll just read this blurb here. Mysteriously, in our galaxy and probably most others, the likeliest type of star to form is almost too small to sustain itself. Red dwarfs, which can be between 1/13th to 1/2 of the mass of the sun, represent 3/4 of the stars in the Milky Way. Anything smaller than this, hydrogen will not be able to fuse in its core, which is, as we know, the dominant process that powers the stars. So red dwarfs burn so slowly that their lifetimes will be longer than that of the present day universe. Sun-like stars are more rare. They represent 8% of the galaxy. And then even more rare are very massive stars, which can weigh as much as 150 suns and only live a few million years. And those are so big and luminous and so short-lived that astronomers are observing these stars in their pulsating, mass-ejecting death throes, while their low-mass stellar siblings are still in the process of forming. And a young star is called a protostar until it can power itself with hydrogen fusion reactions, and high temperature is crucial to that transition. So, as the matter falls in faster and faster, the ball of gas at the center gets smaller and more compact. The tug of war between gravity and the other pressure heats up the infant star. The core of the star must get to about 10 million degrees before it becomes a hydrogen burning machine. And then to be a bona fide star, it must spontaneously fuse hydrogen atoms to form helium, releasing enormous amounts of energy. And then that energy helps stabilize the star's core so that it stops contracting, and that whole process can take about 40 million years. So then with that, so that was chapter 1, and then I just
You said
have
40 million years?
yeah, the whole process I
The
guess
whole
can
process.
take about
Okay.
40 million years,
Wow.
which is that's a long time.
Yeah.
And then I just have a little video. So NASA solar system, life and death of a planetary system, chapter 1.
And that's a nebula.
Yes. So that was chapter 1, and then I'll just briefly go over chapter 2 here quick, and then we can watch this little chapter 2. So chapter 2 is from cloud to disk. So this is kind of talking about a newborn star and how it's shooting out violent jets of accelerated material as it gets nourishment from the gas and dust whirling around it. So their timeline for this phase is 100,000 to 1 million years.
Interesting.
And yeah, I guess really it just seems like the star in this phase per them is getting like it's like a little baby, It's getting nourishment and everything from the surrounding gas and dust, and then it potentially, and then I guess here it says that about 100,000 years, the cloud starts to thin out enough to reveal two distinct structures, a newborn star and a fluffy, diffuse disk of gas. And then sometimes planets can form. But then we'll just watch this brief short video here on chapter 2. Maybe.
I do not hear anything.
Yeah, these ones don't have sound, I guess.
Okay, I just want to make sure.
Yeah. And I think that was the end of that one.
Cool.
And yeah, so that was just from NASA, little chapter 1 and 2, just briefly talking about kind of stellar nebulas and formation of stars.
Yeah. And now that we discussed what a stellar nebula is, we're going to move on to average and massive sized stars in our next video.
Yes, so join us there, and you can always leave a comment below. Let us know what topics you'd like us to cover in future episodes.
You can find us on Facebook, YouTube, Instagram, Twitter, and TikTok, and we also occasionally Twitch live stream.
So don't forget to like, follow, or subscribe, and turn on notifications so that you know when we do. Otherwise, we'll see you all in the next video.